Alright, in this video I want to show you what's called the empirical rule, and it's kind of a rule of thumb that you can use when you analyze the normal distribution. And what I've done here is I've created on Google Spreadsheets this simulated normal model. There are 400 data values, so we can pretend they're test scores or something of maybe an entire class at a college or something like that. So here's what I want to point out. First of all, so we've got a histogram here. It's the distribution. I've recorded the mean and the standard deviation. So what I want to do, and the other thing I've done is I've tallied up, or I've indicated on each bar with the frequency for each bar, so that it can make adding easier. And you'll see that the mean falls into that bar that I've indicated here in red. So what I want to show you is just the tendency that starts to emerge when you have a large number of data values. In this case, 400 was sort of enough to show you what happens as histograms start to become more normal in shape. So I've got my mean here, 79.44. So if I add one standard deviation, again, given that our standard deviation has that length, so if I do 79.44 and I add 9.42, that gets me to 88.6, which is like roughly around like here. Right? It's not exactly there, but let's just kind of ballpark. That is one standard deviation above. And if you do 79.44 minus 9.42, you get 70.2. So let's just use use that as roughly the cutoff for one standard deviation below the mean. So what I want to do now is show you something. Again, I know there's 400 data values here. So I am going to add up all of the scores, or the number of scores rather, between one standard deviation below the mean and one above. So what I'm going to do is I'm going to do 26, right? There's 26 data values right above this blue mark. So 26 plus 35 plus 33 plus 28 plus 29 plus 25 plus 33 plus 29 plus 26. Okay. So basically what I've done is I've added up the number of data values within one standard deviation. Okay, so within one standard deviation of the mean, there are 264 data values, and if we divide that by the total 400, that gives us the percent, which is 66%. Okay, it's not even about, it is exactly 66%. So I would say 66% of the data values fall within one standard deviation of the mean. Now let's go out another standard deviation. So in going out another standard deviation, what I'm going to have to do is I'm going to add 79.44, I'm going to add 9.42 twice. Okay, and that gets me to 98.28. So let's just say that's roughly here. So that was one standard deviation, and here's another one. Okay, and if I go backwards, 79.44 minus 9.42 twice, I get to 60.6, which will indicate here. It's roughly there. So now I want to find out the percentage of data values that are within two standard deviations of the mean. Okay, and so in adding up these values, so again it's 6 plus 1 plus 15 plus 10 plus 23 plus 26, 35, 33, 28, 29, 25, 33, 29, 26, 25, 15, 10, 7, 7. And I got 383. So within 2 standard deviations of the mean, we see that there are 383 divided by 400, which turns out to be 95.75%. So I could say 95.75% of the data values lie within 2 standard deviations of the mean. So the point in doing this is twofold in my mind. First is just to remind you that the normal model approximates histograms, and to find percentages, we really just tally up how many data values there are and divide by the total number of data in the sample. That's the first thing. The second thing is, as this gets bigger and bigger, we're going to see that these numbers, the 66% for instance, and the 95%, those start to hone in on 2 very predictable values. So what we'll see is that in the normal model, in general, about 68% of the data values fall within 1 standard deviation of the mean. And within 2 standard deviations of the mean, it's about 95.75. It's actually really, that one's actually really close. And so if we made n bigger, if n was like 800, we'd see that 66% would probably be closer to 68%. And then, that 95% would be even closer to the theoretical limit there. So that's an interesting phenomenon. And what that basically means is that there are rules of thumb we can use with involving the normal distribution that can get us percentages, if we don't have a calculator on us. And so that's what we're going to look at, and it's called the Empirical Rule. So here we have an idealized normal distribution, and there are a few facts that you'll notice. So first is that 68% of the data lie within 1 standard deviation of the mean. So, and you can see that from the picture. And that is pretty consistent with what we had in the previous slide, right? Because that was 66%, and it was a histogram with 400 data values. And you can imagine that as the data values increase, that percentage is just going to approach 68%. Okay, so when we say something is normally distributed, we're totally allowed to use these rules of thumb. Now, obviously, you can use the calculator too, using the inverse norm function and all that, and the normal distribution function. But these rules of thumb can be handy if you're just trying to, say something off the cuff. And then, therefore, the next concept is that 95% lie within 2 standard deviations. Okay, and then once you get to 3 standard deviations, you're dealing with 99.7%. Oops, I guess I doubled up on the percents there. But so the one thing to notice is that if you are outside of 3 standard deviations from the mean, right? If you're above 3 or below 3, then you're a rare data value. But the other thing we could do is not only do we have these percentages here, but like each red and each pink and each purple section can be evaluated as well. So we'll take a look at that. So we know that 68% of the data values lie within 1 standard deviation of the mean, but that just means I can call by symmetry that section 34% and that 34%. So 34% of the data lies exactly within 1 standard deviation above the mean, and 34% lies within 1 standard deviation below. And together that makes our 68% that we saw in the previous slide. Okay, now once you go to 2 standard deviations, we know that this arrow I'm about to draw has to contain 95%. Let's see, let's draw it here, I guess. So that has to be 95%. So with a little bit of just a little bit of reasoning, you can figure out the percentages of these two sections here, you know, just using symmetry. So 68% is accounted for now, right now. We need to get to 95%. Those two sections together have to get us to that 95%. But if you do 95 minus 68, you get 27. And if you divide by 2, you get 13.5. So this has to be 13, each of these pieces has to be 13.5%. Okay, and so now we're all the way up to 95%, and we know that if you look at the empirical rule, 99.7% has to be within 3 standard deviations. So this arrow I'm about to draw here has to account for 99.7%. Now we're already at 95%, so if you do 99.7 minus 95, you get 4.7, and if you divide by 2, you get 2.35. And then, I mean, so all of that is 99.7%. The rest of the distribution has to total to 0.3%, because that's all that's left, and that means each of these little sections is 0.15%. So, in the absence of a calculator, you can kind of you can do some estimation in terms of what percent of data lies within certain standard deviations, as long as you know that a certain data value is precisely 1, 2, or 3 standard deviations from the mean. You can say something pretty exact about, you know, its relative percentage.